Children, in the previous session we saw how to simplify inverse trigonometric functions. Let us take some more cases involving inverse trigonometric functions. Like here in these one, we are going to evaluate them. We are going to find the value corresponding to them. Like in the 11th one, you can see the expression is given to be tan inverse twice of cosine twice of sine inverse 1 by 2. So we are going to solve it from the innermost part in the reverse order. We will simplify it. Like here, 1 by 2 can be replaced by sine pi by 6. So this part reduces to the form sine inverse sine pi by 6. Because this value belongs to the principal value branch, which is close interval minus pi by 2 to pi by 2. So sine inverse sine pi by 6 can be replaced by simply pi by 6. So this entire thing reduces to twice of pi by 6. And our expression is now tan inverse 2 cos twice of pi by 6. Cancelling out the common factor here, we are left with twice of cos inverse pi by 3 in the parenthesis. Now cos pi by 3 can be defined. Cos pi by 3 means cos 60 degree, which is 1 by 2 only. So this is now twice of 1 by 2. So 2 and 2 also gets cancelled out and we are finally left with tan inverse 1. Now this 1 can be written as tan pi by 4 and the expression takes the form tan inverse tan x. Now can we write it x or not? That will depend upon this angle. If you see, it belongs to the open interval minus pi by 2 to pi by 2. So we can write tan inverse tan pi by 4 as pi by 4. So see, the value corresponding to this entire expression is pi by 4. Then see the next one. It is cot of tan inverse A plus cot inverse A. In order to solve it, you need to recall the property involving the sum of these two types. We have an identity which says tan inverse x plus cot inverse x is pi by 2. So keeping that in mind, tan inverse A plus cot inverse A can be written as pi by 2. That makes it cot pi by 2, which is equal to 0. Then see the next one, 13th. I am naming the expression as z. We will use this notation to represent it every now and then. We have to find tan half of sum of these two terms. If you see, various conditions are written over here. You will find all these will help us in ensuring that the required value or the variable is in the given principal branch and we will be able to move forward with the calculation. In some of the cases I have explained also. See, if you remember the result, you can directly replace it. We all know sine inverse 2x over 1 plus x square can be written as 2 tan inverse x and this can be written as 2 tan inverse y. So if you remember the results, you can do it directly. Otherwise, I have explained it through substitution. Like we can replace x by tan theta and theta can be later on replaced by tan inverse x. In the same way, for y, we can use the substitution tan phi, where phi can be written as tan inverse y. Now proceeding with the calculation, z can be written as tan 1 by 2 times sine inverse 2 tan theta over 1 plus tan square theta plus cos inverse 1 minus tan square phi over 1 plus tan square phi. If you see, 2 tan theta over 1 plus tan square theta is sine 2 theta. So this has reduced to sine inverse sine 2 theta. In the same way, this is the expression for cos 2 phi and we get cos inverse cos 2 phi. Now all these conditions will help you in writing sine inverse sine 2 theta as 2 theta and cos inverse cos 2 phi as 2 phi. Okay, so explanation I have given here, though you can write it directly also because these all are supporting it. Now when they say mod of x is less than 1, that means the value of x must be between minus 1 and 1. Now x has got the substitution tan theta and 1 can be written as tan pi by 4. In the same way, minus 1 can be written as minus tan pi by 4. Or you can write it as tan minus pi by 4. As we know, minus tan theta is tan minus theta. So this is the resulting inequality. If you see, if this is what we have, then theta must be greater than minus pi by 4 but less than pi by 4. And as our angle is twice of theta here, so we multiply each of them by 2. So this reduces to minus pi by 2. This is 2 theta and this is pi by 2. So what do we see? This angle twice of theta is in the open interval minus pi by 2 to pi by 2. And sine inverse sine x is x when x belongs to the closed interval minus pi by 2 to pi by 2. So you have to only cross check. Is your angle satisfying this condition or not? Our angle lies in the open interval minus pi by 2 to pi by 2. So it is taking all those values which are already lying in this interval. Okay. So you can replace sine inverse sine 2 theta by simply 2 theta. So you can see I have continued with the calculation of z. Z can be written as tan 1 by 2 and sine inverse sine 2 theta can be replaced by 2 theta. In the same way, cos inverse cos 2 phi can be replaced by twice of phi. Explanation for that is here. See, for cos inverse cos 2 phi to be 2 phi should lie in the interval 0 to pi, close interval 0 to pi. Now because they are saying y is greater than 0 and y is tan phi, that means tan phi is greater than 0. Or you can say tan phi is greater than tan 0. That means phi is greater than 0, which further implies 2 phi will be greater than 0. Over here we will see, if you see, it fulfills the required condition that angle has to be in the closed interval 0 to phi. So we can replace it by twice of phi. You can see it is more than 0. It will be twice of an acute angle, which is phi, obviously, which will be less than 180 degrees. So see, we can take 2 common here which cancel out with the 2 in the denominator, and we have tan theta plus phi. You can expand it directly from here using the formula tan a plus b and reach the conclusion, or you can convert theta and phi into the original variables x and y. Theta is tan inverse x, phi is tan inverse y, and we can use the formula for it. See, we know that tan inverse x plus tan inverse y can be written as tan inverse x plus y over 1 minus xy if xy is less than 1. So this is how we can write it. And tan inverse this can be written as x plus y over 1 minus x into y. So you can see all the conditions which are being put on the variables here. They are suitable and they make our simplification convenient and easier.